Hello! Today a special version of the Snell and Wilcox TPG21 which generates test card F. Now, some people are going to be aware that there are versions of this equipment which allow the end user to download their own test signals into it. That isn't what we have here. This is actually a non-programmable unit which was sold by the manufacturer with test card F baked into it, which makes this an incredible find. Now, this was actually found by a friend by the name of Steve by pure chance, just knocking around on eBay, and he's actually loaned it to us to have a look at today. Now, the first thing we're going to do in this video is have a bit of a talk about how we got here and why this is quite an unusual thing to be looking at. Those who have been watching the channel longer term will recall that we've done loads of experiments and tests using analog TV equipment. And at the same time, we've done some pretty thorough testing on the patience of a small but dedicated YouTube audience. Now, in thinking just about every video I've ever made, we've used some kind of complex test card for the experiments, and I've even made some videos specifically about the equipment that generates those. And in all cases, I'm using some kind of original professional equipment, predominantly Philips. Now, in light of that, I always thought it would be really interesting to try to bring test card F into the picture and do it in a way that's consistent with some of the stuff that I've done in the past. But yeah, this is a bit of a problematic proposition. Now, roughly 2.5 to 3 years ago now, I started to think about what this might actually look like for test card F. Now, the obvious place that you end up is thinking about maybe some kind of original BBC equipment, and there is a little bit of this around surviving. But what I quickly found is that there's nothing which is either obtainable or in an appropriate state to do this. Now, I think this is the kind of thing that probably could be put together, but it isn't something that I could bring about myself, so I didn't really go any further on that one. What I did instead is head over to the UK Vintage Radio and Television forums, which really is an excellent place to find people with expertise on this subject. And I asked a simple question: does anybody know of any commercial equipment, the kind of thing that could be purchased outside of the BBC, the kind of thing that I might conceivably be able to find on eBay? Now, this question attracted quite a few more responses than I was expecting, but for all of it, my question went unanswered. With no known commercial equipment to look out for, I then went on to research the general prospects of such a thing existing at all, and this turned out to be pretty interesting. Now, there are a number of areas to cover here, but the overarching problem is that, certainly when compared to mainstream test cards for the PAL and NTSC systems, in television engineering as a whole, test card F is actually quite niche. To get a sense of this, we're going to be doing some comparisons with Philips, which broadly speaking was for the same purpose. It's designed for the same television standards, and it could be found in all of the same places where test card F was used. So I think it's valid to do at least some comparisons here. So let's start off by having a look at the broadcast usage of test card F. According to the Wikipedia page, it was used in approximately 30 countries, but it actually only goes on to list 7 here, and of those usages, they appear to be fairly brief, just confined to the 1970s. Take my own country, New Zealand, for example. It supposedly was only used for 2 years. Philips, by comparison, was used for 2 decades, and it does appear to be a similar story elsewhere, and these are long-term usages. Now, the reason that I'm highlighting this is because just take a minute to think about how much physical kit would be underpinning Philips. We're talking probably thousands of units, especially when you consider that in many cases it was generated at individual transmitters. Now, that all having been said, Philips generators are rare. It's very, very rare to find them for sale, and there aren't actually all that many people who physically have them in this day and age. Now, test card F by comparison, the BBC was the only known user of it by the 1980s, and they tended to generate it centrally, so they would have been able to get away with probably as little as 4 units. So you can get a sense of just how much of a unicorn this thing is going to be. While the relatively small on-air footprint of test card F is a factor in the inability to obtain any commercial equipment to generate it, it doesn't actually turn out to be the main problem. The real issue is test card F's near complete absence from commercial television R&D and manufacturing, a sector which once again was dominated by Philips, certainly when we are talking about the PAL market, which test card F was serving. So what's the problem here? Why didn't it catch on? Well, there are the obvious reasons. For example, Philips was just a more accurate test card. It was able to be generated electronically and cheaply pretty much from the start of colour television. whereas test card F was exclusively optical up until 1984. Prior to that, it was neither cheap or accurate to generate. Now in 1984 we did get the electronic version of it, which was cheaper to generate, and it was definitely a lot more accurate. But the accuracy of Philips was not matched by BBC test cards until the arrival of test card J, which unfortunately didn't arrive until the sunset of analog television R&D. And bear in mind, these test cards were predominantly designed for analog. But there's actually another more interesting factor here, which we can find by examining the commercial posture of each of them. The Philips test card was neither licensed or in any way directly obtained. Instead, it was acquired by purchasing an appropriate generator, such as this PM5534. Commercially speaking, the generator is the product, and the test signals which we saw on our oscilloscopes or television screens are the thing that the product does. In short, if you have the thing, you can do whatever you like with the output of it. And this happened to work very well in the commercial sector. The situation for test card F is completely different. For starters, it's not underpinned by any specific physical equipment. Instead, it's actually treated as a single frame of television content, which is subject to a copyright and licensed in a similar fashion. Now, there was a provision for free non-commercial use, which I have to point out, but that wouldn't apply to the thing that I have on my desk. This is a commercial item that would only have been purchased and used by a commercial entity. Now, for the manufacturer of such an item, it's a bit complicated. Not only is your product a professional video signal generator, but it's also an obscure form of distribution media for a piece of copyrighted content, and there would have to be some sort of arrangement in place to allow for that. As for the customer of this equipment, well, not only have you paid a lot of money for a professional bit of test equipment, but also you've got to think pretty carefully about what you're going to do with it and whether or not you are permitted to do so. So yeah, this is all quite a lot of extra friction for a piece of equipment which, as far as I can tell, basically has almost no market. I really can't think of any realistic use case for it, and it's not the sort of thing that the BBC would have owned or used, and I have actually already checked with some contacts and they don't think that that has actually come from them. So it's a bit of a mystery. So anyway, nonetheless, against the odds, it was made, it is real, it's on my desk, and it is absolutely fantastic. So let's get into it. So we've got some interesting stickers here. Customer service asset. So this definitely is saying that this is belonging to a commercial entity, certainly if they have got customers. Do not remove or tamper, not for loan or sale. Whoops. Yeah, I don't know if that's just a generic sticker that this owner used, or is that referring specifically to this unit being a bit special and having some specific legal circumstances around it? Don't know, possibly. And we've also got, by the looks of it, a traceable calibration certificate for it, which is referenced there, which is also quite interesting. So whoever owned this was keeping it in good calibration up until 2010, which is it just keeps getting better, doesn't it? So not only have we got a professional test card F generator, we've got one that's even calibrated. And the location here is Camberley. So this is suggesting this probably belonged to one of the several television equipment manufacturers that was located in the Thames Valley. But there's no clues on here as to which one that is. We'll start off here by having a look at the physical product, and then we'll talk about what's specific about this version of it. The TPG21 is rather different to any other test pattern generator which I've ever come across before. The first thing that kind of jumps out at you is that we have 3 full bandwidth outputs, which is quite an unusual thing to see in a test pattern generator. So that makes this a full component generator. But whether or not it is actually generating component depends on the test card which is actually selected. So what we've got here is 3 10-bit DACs, and we also have 1 to 2 oversampling filters, so 2 times oversampling. And the sample rate of this unit is 4 FSC, so for PAL that's 17.73 megahertz. Once again, not as common. I think Tektronix, I have seen that in Tektronix, but nowhere else. And our filters are not all that special because this is 2 times oversampling. These are only fairly basic, but it looks like we do have some adjustments at the back of there. But the thing that's really interesting and different about this unit is if you look inside all of the competing generators, they generally read the samples directly out of Eproms like these. But this one actually reads them out of these SRAM chips, which is That's quite interesting. So it looks like the way this thing works is that it loads up test signals out of these EPROMs via the CPU into these SRAM chips, and the CPU possibly does some transformation on it in the process, maybe just decompressing. I'm not sure. Now this is quite, yeah, it's quite an interesting architecture, and it means that you can potentially, you could do some interesting stuff with this. So for example, you could have the test patterns in component form, generate them as PAL or generate them as CCAM or whatever, just in the CPU here. I don't know if they actually do that, but that certainly would be a possibility. And it also means that animated features are a lot more straightforward. And that is something which competing generators, certainly of this era, kind of struggle with. I don't think Tektronix and Rod and Schwarz do anything. Philips sort of do. They've got this kind of convoluted mix of SRAM and EPROMs where they have animated stuff in SRAMs. But anyway, so yeah, it is quite advanced for certainly compared to what else was on the market at the time. Now there is one drawback of this architecture, which is that when you're changing test cards, you've got to sit there waiting for the CPU to load the test cards out of the EPROMs into the SRAM. It takes a few seconds. I guess if you were an engineer, that might test your patience eventually. Whereas the competing generators can just flip through all the options instantly, which is quite a bit nicer. There is another possible disadvantage of this too. It may be that this generator is not able to track the subcarrier phase of a reference input when it's in genlock, which would mean it's not great for broadcast use. I'm not certain of that actually. I'd be interested to actually test that out. If it can, that would be extremely impressive. So the real question here is, how does this differ from an ordinary TPG21? I know there are some people who watch the channel who have these things, so you guys are going to be quite interested to see this, I would imagine. Now the difference is down here in the ROM section. So we can see we've got 5 EPROMs, and these are the ones which contain all of the test signals. This one here contains the test card F image. A couple of things which immediately stand out about it. Number one is that it's tcf1.bin, so this is some special type of file format which probably is only understood by this generator. The other interesting thing is the label on it. No question this has come out of the Snell and Wilcox label printer, so yeah, no question that this did indeed come this way. It hasn't been modified after the fact. So what's actually in here then? Well, when you select test card F, only the composite and S video outputs are available. You can't have it in component form. So that would suggest that this is some kind of pre-encoded format of some sort with some sort of compression. And it's really only a generator like this that's going to be able to make use of it. So something which has, you know, just a raw DAC as an output, reading from memories. And it's going to be something with a sample rate of 17.734 megahertz, so 4 FSC. So yeah, there's sadly not a lot else we can really do with this other than run it in this generator, unless we want to have some huge difficult project to try and create something else, or make a whole lot of software modifications to it, at which point it doesn't really become very authentic anymore. Now, I think one of the questions I immediately had is, what does an ordinary TPG21 actually look like? And we do have some pretty good insight into what the product is here. Now, Brian Summers has actually sent over this scan from a Snell catalogue, which does give us some pretty good insight into what we're actually looking at here. Now, it does actually say here that it is the TPG21, which has a downloadable feature, which I mentioned in the opening of this video, and the TPG20 doesn't have the ability to store things in a non-volatile way. Now, if we look on the board here, there's no flash memory. There's either EPROMs or there's SRAMs. There's no way you could go and put a test card in and actually have it stay there on power off. So that's actually suggesting that this is actually potentially not a TPG21, unlike it's suggesting on the front panel, but this is actually looks probably like it's a TPG20. And it must have been provided to the customer that way because they weren't interested in the ability to download their own test cards. They just wanted a test card F generator. And it does do other things, so these EPROMs do contain all of the basic Snell test signals, which you would find in a catalogue unit. Now, I also happen to have a catalogue version of the TPG21 here, so let's have a look at that. Here it is, and this is actually a unit which belongs to me. It's just an ordinary bog standard variety of TPG21. Now we can we can see immediately that it's quite different. So this 24 megabits of flash PROM, which is mentioned on this catalog page here, we can actually see it right there. So six 4 megabit chips. So that's 24 megabits. We can also see that we have 4 EPROMs present. So it looks like the TPG21 really it comes about just by attaching this mezzanine card to it, and it's plugged into the EPROM sockets, the 5 EPROM sockets underneath. But the main board of the other unit doesn't have the screw holes, so no question that that is a TPG20, despite it being marked 21. Now, I don't know if that's standard practice for Snell, whether or not they just all mark them all as 20, I don't know. Couldn't find a picture of a TPG20. So anyway, there you have it. It is definitely quite a special unit, this test card F version, and looks like it's been put together to order, I would say. For a bit of extra fun, I've put together a little pedigree here, a hand-drawn one, because I seem to be just too lazy to do any actual graphics these days. And this is really just to try to place this EPROM. So what I'm trying to do with this diagram is explain, for example, me as an ordinary member of the public, and I'm looking at test card F, how did it get to me from what I'm referring to here as the original data? This is a data set which was put together by the engineers in 1984. It's the highest quality possible copy of the electronic test card F. In terms of what it is, I don't have any technical details on it, but it's going to be something which is high dynamic range, it's going to be lossless, and it's going to be something fairly obscure because back in those days, none of the PC file formats that we use today existed. So the most likely route people would have seen it back in the day is through a broadcast. Broadcasts mostly came from a piece of equipment which is called GE6M. I showed a picture of a version of this that the Science Museum has back in the beginning of the video. I tried to get an appointment to see that one, but I didn't get anywhere with that. It doesn't sound like they've got enough resources to let people look at things in their warehouse at the moment. But their one is programmed up with test card F. Now, fortunately, once again, Brian Summers has been very kind to us, and he's actually sent us some pictures of his unit. It's not a test card F generator, it does something else, but it is the same hardware. So from the original data, a set of EPROMs would have been built, and those are plugged into a card in this unit. It then uses those EPROMs to feed a set of 3 DACs, which are on 3 individual cards, one for Y, one for U, and one for V. They're all identical. They're 8-bit DACs, fairly early technology there, so it's the TDC 1016-8 on there, which, as I say, is 8-bit. From there, it's sent down an analog transmission chain, and that's how the public generally would have seen it. But later on, there became a new way to view test card F, and that was through a GIF file. This is an important artifact, this one, because it came from Richard Russell, who is a well-respected and trusted source of this stuff, and he used a piece of software that he wrote to generate it from this original data. So this is, as I say, this is quite a special one because we know its story and its history. Now, people don't necessarily like this version because the quality of it isn't amazing, and it's got a big copyright message on it, but that was the terms he was allowed to do this on, and so we do, of course, have to respect that. Now, there is actually another genome of test card F floating around, which is a bit mysterious. It comes in the form of a JPEG file. I've seen a number of different versions of it now. It seems to be higher quality than this one, and it's got a full color depth, whereas this one is only 256 colors, obviously, it being a GIF file. I'm not actually sure of the origin of this. It seems to be a bit odd. I've not ever seen it with any kind of copyright message or anything attached to it. I've heard that at some point this got turned into something like a TIFF file, which may be available to some people inside the BBC. So it's possible, and I'm just speculating here, that somebody saved that as a JPEG at some point and that has escaped containment, but I don't know. If you know anything more about this one, let me know. Now anyway, the interesting thing about this EPROM is that I'm also told that Snell and Wilcox, because of their closeness to BBC R&D, they had access to this. And it's very likely that they have generated this EPROM directly from this original data or via some other format which they use internally, which makes this quite special because it is a new, previously unknown genome of the electronic test card F, which up until now, probably very few people other than me have ever actually seen. So it's really quite special. Now the other thing that's really special about it is that it is able to exceed the quality of all of these. So turning this into an analog video signal, it would be higher quality than the original broadcast, because this is 10-bit. The broadcast was 8-bit per channel. Way higher quality than the testcardf.gif. And also probably higher quality than the JPEG as well, because bear in mind that this is a lossy image format. There are artifacts in there which would show up on an oscilloscope, whereas this is very clean. This is I say I have looked at this, and it does look pretty nice. And we'll have a closer look at it in a moment. Now, as I said before, it is a composite format, so it's a composite and S-video, which some people might be disappointed about, but I'm very happy with that, because that's the way that people received it off air, and so to have really the highest quality possible realization of that is that's very special. So it's a really nice find. What I'd like to do before we get into any experiments is make a copy of this so that I can generate testcardf from my unit here. Believe it or not, this is not something I was even going to bother with originally, but having thought about it, yeah, this is actually quite historic, so I would like to keep this capability here. So how to actually go about it? Well, as I said before, these units are a bit different. Now, my original plan was to just copy these 5 EPROMs, take out the mezzanine card, and just plug the 5 EPROMs into the mainboard of my TPG21. And that certainly should work. I mean, the boards are slightly different, but they have got all of the same code in all the chips. There's some jumpers on this board here which are not present on this one, so maybe I would have to fiddle with those. I don't know, but I think that should be able to be made to work. So what we have here is 4 megabit EPROMs, the ones containing the standard Snell patterns, and then we have an 8 megabit EPROM which is containing the testcardf in a 32-pin package, which is that's rather unusual. I don't actually have one of those to hand, so I ordered one, but then I got a bit impatient waiting for it, so I did some reverse engineering on this, and I don't reckon that's actually necessary. So the way this thing works is that in these EPROMs, the test cards are bundled up in little packages, which is quite innovative actually. When the unit powers on, the CPU will go and grope through the entire 5 megabyte address space which is occupied by these EPROMs. And it doesn't actually matter how they're laid out, just so long as each test card is unbroken and complete. So what I should be able to do is dump the code out of this 8 megabit EPROM and then program it in somewhere on this board. So I dumped out all of these. These ones are containing the ordinary Snell patterns and Snell number 2. These ones here, from memory, contain Snell number 3. These 2 are Snell number 1, and these 2 are available. So what I'm going to do is split the testcardf EPROM into 2 4 megabit chunks and program them onto these 2 and see if that works. Based on what I've seen so far, that should be fine. Let's give it a go. Okay, so should be able to go into the pattern menu and select, hopefully be able to select testcardf, and it's in the, where is it? Others menu, because yeah, if you're actually doing professional engineering work, you're probably never going to use anything from this menu, or certainly very rarely. So someone seems to have selected Snell number 3. So there's number 2, 3, test 1. Test chart F. There we go, and it is test chart F to you, sir. There's a bit of Snell terminology, but all working nicely as I had expected. Very good. So we actually now have more test cards in this unit than the one below. This has actually not got much in the way of the complex test cards from Snell. So one of the things I'm going to do for the chap who owns this is to try to transplant some of the test patterns out of my unit into his at some point. Now, unfortunately, we're not going to be doing an in-depth dive into testcardf itself in this video. Doing that would take me weeks to put this together, and if the lack of uploads lately isn't a clue, I've got a lot of other stuff on at the moment, and I just can't really do that right now. However, if you do want to know more, there's of course loads of information around the web, and if you want to look at a YouTube video, I would definitely recommend heading over to the Dexters Tech Lab YouTube channel. He's got a pretty good video which talks about test card J there, which is very similar to this one. So yeah, definitely check that out, and I'll put a link in the description. But what we are going to do in the remainder of this video is some quality comparison tests. Tests which I've been wanting to do for a long time. So here's our test setup, Philips generator and test card F generator. Let's just chuck that on the TV now. So we're going to be checking both of them in composite, even though we do have S-video available for both units, mainly just because that's how people actually received it. So we'll just focus on looking at the waveforms on the oscilloscope, and we'll have a quick check on the Vectorscope later on as well. To start off with, we'll have a quick look at our Philips, and we're just going to run through some of the basic things that I would expect to see in a good quality video signal. First things first, DC levels. It's amazing how little equipment can actually get this right. So I want to see 0 volts at the blanking level, or almost nothing you plug in other than professional test equipment seems to do that. That Mach 1, the Snell Mach 1 we looked at in the last video was okay. I think it had a bit of an offset, but yeah, this is perfect, exactly 0 volts. And I also want to see exactly 1 volt between the sync tip and the white level, and we have that, so that looks pretty nice. Next up, I want a nice clean burst. I don't want to see something that looks like a peanut. That looks really nice and flat all the way across. And the other thing it looks trivial here, but this is surprisingly difficult to get right, is a transition between white and black. So there's a lot of ways you can go wrong here. You can end up with ringing at the beginning and edge of that transition, and you can also transition too quickly. So if this rises too quickly, you end up with a high frequency burst, which will end up in the chrominance decoder of the receiver, and they will actually see some colors around this transition from white to black. So yeah, I say it looks trivial, but there's a lot of thought that goes into just getting something simple like that right. And next up, any areas with this color, once again, I want to see that this is nice and flat, and this is all looking pretty good. But I have spotted something which looks a bit dodgy on here, which makes me question how well adjusted this unit actually is. It's a bit of ringing. That shouldn't be there. What else we got? Once again, a bit of ringing. Yeah, I don't know. That doesn't look right to me. I think I might have to go and check this one at some point. But overall, it's pretty clean. And this isn't the cleanest Philips generator I have. I have better ones. I just got this one out because it's older than the Snell, but at least it was on the market at the same time as the Snell. So looking on the Vectorscope, here's our primaries around here. So these will be all the colors which appear in the Philips test pattern. And we can see the dots are roughly falling in them, but not quite. Now I don't know how well calibrated this Vectorscope is. Well, I know it's not well calibrated. I've not got the manual and I don't know how to calibrate it properly. But it's not looking too bad, so we're set for 75% here, and that's showing up as a 75% as we would expect. The other thing I would check is the lines that run between the dots, and I can actually see a defect in here. So if we look between YL and R here, there's just a bit of a bow. There's a line, this line goes that way, and then this one comes back that way, so there's a bit of a gap between those two, which would indicate there is a small defect in the Powell coder on this unit, or the filter or something, which is really annoying because that means I'm going to have to sort that out. But anyway, at least I know it's there, and it would be perfect if I plugged in one of the more modern generators. I just got this one out because we haven't had it out for a while. So I've just changed over to the output of the TPG21 generating test card F. Now straight away it's looking pretty good. So our blanking level is at 0 volts, which is good. And our sync tip to white level, I'm measuring 1.03, a little bit higher than the 5644, but I don't know how well calibrated my scope is. Moving along, looking at the burst, very nice. That's not actually part of the test card, but good to check it, just make sure it's clean. Now we're actually getting into the test card itself here, and this will be one of the bars, the red across the side. amplitude of that subcarrier a little bit lower than the white level. I would expect them to be lined up, but still looks pretty nice. It's perfectly acceptable. And a monochrome feature here, some sort of white stripe. I think that's the one running along the edge. Very good, very symmetrical, very clean. And we have a little pulse here. Really nice, really, it's really good, and that's yeah, that's pretty nice. You know, considering how rubbish these things look when you look at them in GIF and JPEG files, that's exceptional. It's really, really nice. Some other feature there. These are just white pulses. This here is the black stripe, which runs across the top center. Look at the symmetry on that. It's just perfect. And also the white and black. You know, you don't see any. There's absolutely nothing, no distortion or any, no noise in here. So if you were looking at the GIF file as a video signal, you'd see a bit of up and down here because it has to dither to get the right grey level. Whereas this is just bang on. It's perfect. Really good. Right, so let's have a look at some of the other lines. We'll go down the test card a bit. So we're now going into the circle. So you can actually start to see the image appearing in the center. It all looks a bit messy because it's a photograph. That's never going to look very nice as a test signal, but I'm sure it's a very nice realization of it. And once again, you just look at all the features on here, particularly the monochrome features. Just look at the perfection of them, just how clean it all is. Just it's just amazing. I mean, yeah, I didn't think I'd ever actually get to see this. Yeah, real good. So this is not just a video signal containing test card F. This is a proper engineering test signal. Really nice. Now there is one thing I was quite interested to look at, and that's actually the frequency gratings which appear on the right hand side. Here they are there. So let's go to one of the lower frequency ones. I really want the lowest frequency one possible. There we go. Right, that is interesting. That's really interesting. So this is one of the things I've always really wanted to see up close on an oscilloscope. What we've got here is not a sinusoid. This is so it's not actually very pretty. This is, I can't remember what this is off the top of my head, but yeah, this is the lowest frequency grating. Now, I wasn't sure whether or not we would see this, because with the electronic test card F, they did have the opportunity to write over these with a proper, true sinusoid, but it looks like they're actually, the features here look more similar to the optical test card, where you have fundamentally got the advertised frequencies and the gratings there, so that's a higher one, and that's a higher one. So you've got they are there, but because they're not a sinusoid, that one actually looks quite reasonable. But yeah, that low frequency one doesn't look very nice. Yeah, so because that's not a sinusoid, you will fundamentally have the advertised frequency in here, but you'll also have various other frequencies. Actually, it does say the scope is actually telling me there it's 1.5 megahertz, that one. So yeah, that's not amazing. Now I have actually already checked this on test card J. Now he has actually overwritten these. Well, he wrote these out with the correct sinusoid here, so this is very nice on test card J. But yeah, this is one of the things about test card F that is not ideal. I'm actually not aware of any of the other problems with it, but apparently there are various other issues with it. But anyway, yeah, that's fantastic. And yeah, if you looked at this on a Philips generator, you would see a perfect sinusoid here, because they do have a true tone there, which is one of the easy things to do, given that they are either electronic or software generated. So yeah, very nice. All right, I think that's. I think we got a pretty good sense of the quality of this, and yeah, as expected, it is exceptional. So really nice find here. Last but not least, test card F on the Vectorscope coming from the TPG21. Immediately, it looks extremely good. So our dots are all landing perfectly in the boxes here, in the primaries. So our subcarrier amplitude is bang on. Now for memory, I actually adjusted this Vectorscope against 2 of my PM5655 units, which are all digital, very accurate. I trust them. So it's actually very reassuring to see that they are agreeing with the TPG21. What I was a little bit surprised to see is that we're on 75% and we're seeing 75%. I thought test code F was supposed to be 95%. That's interesting. I don't know what to make of that right now, but anyway, that's what we're seeing here. But otherwise, it's incredible, really nice. Now these lines don't look clean because this thing has got a photograph in it. It's not going to look pretty on a Vectorscope, but of the bars we can see here, yep, bang on. Well, what a fantastic thing to find. I find test card F particularly interesting, not for the technical reasons, but actually for the non-technical reasons. It's a television engineering artifact which also exists in the realms of popular culture and politics. Yes, politics. Now here in the UK, it's quite interesting in that it's something that tabloid newspapers and gossip magazines will write about, which is, yeah, that's just really quite unusual for something which, say, came from a television engineer. And legend has it that in New Zealand, where I'm from, the test card got itself into some political difficulties. Nothing particularly serious, but in the centre of it, there's of course a person who has a particular race, and this happens to be a race of people that aren't the original inhabitants of the country. And long story short, there's various grievances and difficulties and relationships and so forth between the two. And test card F, by no fault of its own, got caught up in the middle of that, and this was something that was addressed specifically with a more diverse version of the test card, which was called T1. I can't find a single person that has ever actually seen this, but captures of it were made, as apparently it was something that was very briefly used. But anyway, the actual role of test card F here in the UK is also quite interesting. It started out as being something that was used for technical reasons, but over time, it looks like those have faded, and it actually became a sort of mascot. Engineers are, by the looks of it, just getting it out because it's something that the public are familiar with, or something that they like, which is pretty cool. And certainly for me, to have a really nice, high-quality bit of test equipment that generates it to such a level of fidelity is it's just amazing. To have a professional test card generator that generates a test card that mostly, in the end, just existed because people liked it. I absolutely love it. Now there is, of course, more to look at for the TPG21. There is a piece of software called Pattern Master, which looks tremendously interesting. And I'm going to put that on the to-do list to have a closer look at some point in the future. But anyway, that is all for today, and thanks for watching.